Okay, so welcome to this session. We're going to be talking about dynamic languages running in Silverlight. Talking about a whole slew of dynamic languages, from Python to Ruby to Visual Basic to JavaScript. I assume all of you sort of saw Scott's keynote where he talked about what we're doing in building a dynamic language runtime to work on that. So I'm an architect on the CLR team. One of my thoughts for the session is to just tell you guys all about how the architecture works, show you a lot of block diagrams, talk a lot about the theory behind it.
No. We can't be doing that, right? Because, like, if you think about it, right, what do those guys really care about? Right? Like, I realize that you've invested, like, years of your life, right, into building this thing. But the reality is they're much more interested in what you can do with this thing.
Well, so wait, who wants to see block diagrams? Oh, okay, so we're going to have to show them the block diagrams before the session's over. Yes?
The goal is to please as many people as we can. Who are you?
Oh, yes, we'll introduce ourselves. So, oh, we're sitting in the wrong way. So I'm Jim Huguenin, and I'm an architect on the CLR team. I'll tell you a little bit more about my story later on into the talk, but you can think of me as either the PC guy or the Python guy, depending on your...
Very good. I'm John Lamb. I'm a program manager on the CLR team, and so I'm kind of here because I really...
You're not on.
Oh, technical.
This isn't for your benefit. We know John speaks loud enough for you to hear him.
There we go. This is for posterity. So there's a story that I've been dying to tell.
Yeah.
Right? And I think this is the perfect place for me to be telling that part of the story. And the story really is that dynamic languages are particularly compelling in the web scenario because it's just text, right? So the idea that the XAML is just text, your HTML page is just text, and the code that you write is just text is really interesting, right? That's a really compelling story because the community, you guys out there who haven't seen this thing yet, right, will be able to learn in a collaborative fashion out there, right? By some guy posting a sample, some other guy taking that sample and extending and doing some interesting things with it, right? So I think that that is a really interesting, that's the spirit of the web, right? The web was fundamentally a text-based technology, right? So I think that this is really nice. It allows us to have a lot of this rich stuff, right, while still kind of preserving a lot of the original spirit of the web.
So why does it somehow seem weird to me to be talking at a designer conference about the value of text-based technology? Is there...
Yeah.
Yeah?
Well, like I think, part of it is the fact that we really need to have some things that we can show, right? To really kind of drive this point home. So this DLR thing that we have here, we have 4 languages that we fully intend on shipping on top of this thing that we being Microsoft, I'm still getting used to saying that, are going to be putting together. And what we really want to have is other folks from outside of Microsoft to start coming along and starting to build some languages on top of this. We've got a couple of events, just so that you guys know about this. We have a compiler dev lab at the end of May where we've already invited a bunch of folks to come. And later on, we have a lang.net conference as well. So for language implementers in the audience, right, that have a language, please make sure you contact me, right, or Jim, yeah, right, to get on the list for those kinds of events as well. Okay?
And lang.net was fun. A lot of people were kind of shocked by our DLR announcement yesterday. The compiler geeks who came to lang.net last year weren't terribly shocked by our announcement because that was when we first started talking about these kinds of ideas. So,
And Jim even had, like, I've got a photo of this, right? He even had, like, this block diagram which had dynamic language runtime actually as a component inside of that.
So I think we better get on to showing them some code if we're going to have time for me to talk about other stuff later on. So.
Okay, so
Jim? You're going to make me type, aren't you?
I'm going to make you monkey for me for a while. And, but this is equal opportunity monkeying, right? I'll do some of this in a moment. So
we need to switch
to the Mac.
Yeah.
There we go. Okay. So I thought that what we would do is we would start off by putting together a simple application for you. The simple application we're going to start off with Hello World effectively, right? So we're going to grab an existing sample application. Jim, why don't you just run this thing? All this thing has is it's got a text box in there. You can say something there and click on the OK button, and it says Hello Mix, right? Not particularly exciting here. Right, but for developers, we get really excited about this kind of stuff. The server here is Lighty. Light TBD? Lighty. Yeah, you know, it's the trendy Railsy server. So what we're going to do now is we're going to go off and grab some files, and we're going to copy into our directory. And Jim, why don't you just take a look at that, and let's just go back to TextMate, and we can go look at app.html. So this is the canonical HTML bootstrapping page, right? So inside of there, the interesting bits inside of this page really are that reference to Silverlight.js up there at the top, right? Which is essentially a script that just knows how to bootstrap load, you know, just in case the user doesn't have Silverlight installed on the machine. That's the thing that does all the hard work. And then down below, right? Let's get rid of that stuff, right? We're not going to need that stuff.
Thanks.
Yep. And then down below, what you'll see is that create Silverlight chunk of code is the thing that actually bootstraps everything into existence, right? So let's switch over to app.xaml. Right? Actually, app.js is fine. You know, go to app.js, and you'll see there that this weird chunk of code there, app.xaml is the only really interesting piece in there, right? So this is the link between the HTML page, right, and ultimately the XAML page. Right, so let's go over to the XAML page and take a look inside there. All of the magic happens in that x:code tag that you see up there. X:code tag, as you can see, now points to an app.py file, right? So this is a Python application that we're looking at. But in the spirit of, you know, Ruby's coming out party here, right? Why don't we convert this sample to Ruby, right?
You sure you want to do that, John?
Yeah. Like I think I've got a lot of confidence in our implementation. We should be able to at least handle this. So there's text.ruby there.
Little do you know how much this pains me.
I know. So let's go off and we'll create app.rb now. Okay, so we'll do the transformation before your very eyes. So let's just make all that stuff go away, right? Because I think there's way too much code up there right now. All right, so let's define a function. So let's go back to the XAML page so you guys know exactly what we're defining here. There's a canvas, there's a loaded attribute there, which points to initialize, right? So this is essentially the function that gets called when the page gets loaded, right? So what we're going to do is we're going to go off and write that function. We'll def initialize. Takes two parameters, a center and an args. And and inside of here, what we want to do is we want to wire up something to happen, right? So we're going to have some text there. We're going to have this text block control, right? We're going to click on this thing. When we click on this thing, some event handler has to trigger. So in Ruby, the way we would go off and do this kind of stuff is we would essentially define a block, right? That's going to receive the event. So output dot. Oh, and this is just so hard for you to type, I know. But mouse left button down. We have a fix for this, by the way. We'll show you that later on in this talk. Center and args, yep. And
okay, what do you want me to do?
Let's just say hello mix. Yeah, there we go. So let's close. Remember what language you're in now? There we go. Yeah, I know. It pains you to type all that end stuff, right? But we don't have that tab in space.
Just seems unnecessary if you just pay attention to white space, but...
All right. So let's make that text block do something interesting, right? So let's put some text there first. So yeah, the canonical example, right? Let's make the font really kind of developer-ish. Right, there we go. And let's move it down a little bit, right? So canvas.top, right? Let's move it down like 100 pixels. This will come in handy later. Okay.
You happy?
I think so. You guys happy? Think this will run? There's always a whole bunch of human compilers in the audience.
You think this will run? On the first try?
Well, let's keep going back. You gotta delete some more stuff. There we go. Up. Hey, there we go. So we got Hello World running in Ruby. All right. So, but we can do much more than that, right? So, you know, you guys won't be so impressed. It's time to go home, right? We're done. So
works for me.
So this is one language, right? So we've got Ruby as the language that's now driving all of this stuff. The next thing that we want to do is, the first thing you're going to discover when you guys get home and you're starting to play with the bits is you're going to wonder, well, where's my button, right? Because you saw that original example, right? It actually used an HTML button, right, to actually trigger in the text block and the rest of that stuff? Well, the reality is we don't have controls yet, not in this set of bits that you guys have right now. Right? But there are a set of controls that folks have written as a set of samples, and you'll find the sample for the set of controls inside the SDK. Now, the samples were actually all written in C#. So wouldn't it be cool, right, if we could just simply go off and grab that sample, right, some of the code out of that sample, right, which you're seeing right here.
Can I show them the sample first?
Yeah, you can show them the sample. Woohoo, it's another exciting developer sample. Where we have that button, that really nasty looking button there, right, was of course written by a developer, and that's a C# button. So why don't we go grab that file? So it's in samples, button, Silverlight.
No?
Yep, Silverlight. Yeah.
Can't I just do star.dll?
Yeah, do star.dll.
I want anything that's a DLL.
Yeah, that's fine. Yeah, you're brave. Okay. So now that we've got that in there, let's go back to TextMate and take a look at the implementation of that sample.
Okay.
All right, so we go down into button there. Let's open up button.py. So that's what we do here. Right, so if you look up at the top there, there is this, you might not want to highlight, it's hard to read. Silverlight.samples.controls. Right, so what that does is it essentially tells our downloader, right, to go back up to the web server and download that DLL back down to the client. Right, and that's just a compiled C# assembly there. And then down below, the rest of the stuff is just how you wire up a button. So let's convert this to Ruby as well. Right.
So how do I import something in Ruby?
So let's do a require, right, which is the way you do everything else in Ruby. Right? So require that thing. Oh, not that much. Okay, that's good.
Better?
Yeah. So now we've essentially gone off and this will now tell Ruby to go off and download that assembly. Now, the next thing we want to do is we want to do some namespacey things, right? There's this giant namespace in front of this, right? So let's define an alias for it. Let's say controls is equal to that scary looking thing, right? Let's paste that in there. Okay, so that effectively in Ruby we just defined a new constant there, right, on that next line. Now, down there we need to go off and create a new instance of the button, right? So button is equal to controls.button.new. Right, so we got one of those. Oh, no, you don't need that. No. Yeah, there you go. Right.
Hey, TextMate put them in. It wasn't
no
my
irritating
fault.
superfluous parentheses in this language. All right, so let's go button.text is equal to whatever you want.
I'm feeling very creative this morning.
How many times have you done this so far today? All right, so we've got button.text there, and we now need to wire up our event handler, right, for this button. Right, so the same thing as we did before. But this button, though, rather than having the nasty mouse left button down thing, has an event called click, surprisingly enough. Right, so we'll do button.click, does that, and so far so good. Now, we still have to add that button, right? We just kind of created this button. It's floating around in outer space. Right, so we want to take that button and shove it into the tree, right? So let's do that.
It's this thing called root.
Yes.
You remember?
Yeah, let's go
I'm
back
going
to
to show
the,
people how I
the
figured
Pi
it out.
file. Yeah, it's
It is
root.
called root.
Yeah. So root.children.add. Let's see if you can do it. Ah, yes,
I didn't even type any
He
parentheses.
did it. I'm so proud of you. Okay. All right. So we've got all that. You guys think this is going to work? Let's try it.
There's the button.
Yay! Right? So that's pretty cool, right? We've got some C# code, right? And we've got some Ruby code all running inside of the same application.
Can I just take 2 seconds for a philosophical point?
Absolutely.
To me, what's coolest about this is, we're going to show you a bunch of dynamic languages talking to each other, which is pretty cool. But I don't want you to miss this point, right, of them just talking to C# code too also. Right? There's all of these static languages out there on the platform too. And when we want to use those buttons, we use them, right? We don't create wrappers around them. We don't treat them as some sort of foreign type system. They're natural objects to the dynamic languages, just like the dynamic objects are.
Yeah,
Okay.
so think about it, right? Like,
Soapbox done.
we can go essentially grab any, well, not quite any random assembly, right? But quite a lot of assemblies. If you have source code for those, it's easier. Then you can just make it work, right? But because remember, right, we've got a subset, right, of the .NET libraries, right, that are on the client, right? So if your C# code does some weird stuff with things that aren't there, well, it's not going to work. But assuming that all it's doing is using that subset, then you should just be good to go, right?
Okay, can we make this look any cooler?
Well, since I'm the guy that's token dressed in black here today, right? Let me show you a somewhat different example, which that's some other guy at Microsoft that's actually got long curly hair and dresses in black and all that kind of stuff. He wrote this other sample, and
so the day that John is representing the designers for the team is scary.
So let's.
This is going to be, and what John's going to show you here also is a sample built-in JavaScript, which is another one of the platforms. And one of the most interesting things about being able to run JavaScript, so this is a managed implementation of JavaScript. It runs on top of the DLR, on top of .NET, works with all the other languages. Sometimes you get the question, well, but there's already JavaScript in the browser. Why would I want this? Right? There's a few key advantages to why you want it. So sort of one of them is it's really well integrated with all the rest of the platform. So it's trivial to take this C# button that I just built, and we can use it from JavaScript, and we can do that sort of interoperability. It's also working very hard to be ECMAScript 3.0 compliant, and having a fully compliant JavaScript engine to write your code against is very nice. What's coolest about having this to our language, though, is there's a lot of code that's been written using browser-side JavaScript. This sample that John's going to show you was actually first written using AJAX-style JavaScript in the browser, programming against Silverlight. And it took about 5 minutes for us to take the code, make a couple of changes here and there, and bring it into the JavaScript running inside, on top of .NET, inside of everything. So it's a way to get access to that whole wealth of samples that people are going to be writing using AJAX-style code against Silverlight. So,
okay, yeah. So let's go off and. So in the best tradition of the web, right? Since Jim and I obviously have absolutely no kind of like artistic skills whatsoever, we're going to steal this code, right? So let's go off and grab the stuff out of here.
You can just grab the whole
This
thing.
is just a bunch of really scary looking XAML. Oops.
I thought you were the one who knew how to use this keyboard. And
Yeah. So we're going to grab a bit of this, a chunk of the scary-looking XAML here, and we're going to paste it back into here. And without really understanding what it does, but that's not really the point of our talk here. But like so much code that happens, right? You just go off, you search for a bunch of code, you find it, you shove it in your app. Okay, so now that we've got that little piece working, right, the next thing we have to do now is copy one more thing, right? There's a bunch of these crazy assets, right? As I'm discovering, a lot of these designer guys really like a directory called assets in their thing somewhere. So, samples.
So you want to copy all of those. You don't really want a CD there, do you?
Pardon me?
You're going to do a recursive CD?
Yeah, exactly.
Never seen that before.
Oh, sorry. Yeah, that's fine. Okay, so now we've got our assets in place and that kind of stuff. Let's come back here. So 3dtext.js. Now, if we look at the original code, right, back over here inside of the 3dtext sample itself, there was an initialize function up here at the top. Right? This initialize function essentially goes off and shoves all that stuff in there. So what we're going to need to do in our application is import this file. Right? We're not going to do anything. We're just going to take this file as is, and treat it as a module, and just import all of that code into our existing Ruby application. All right, so let's see how we would do that. So let's go JS is equal to require, just like how we bring everything else in. And so for the Rubyists in the crowd, this is a little bit weird here. Right? But I thought that this was a reasonable thing. We're going to put this out to the community for folks to comment on. But this felt like a natural way of extending require so that we can do this kind of stuff. And we want 3dtext.js, right? So we're going to grab that file. And once we've got that, we can now go in here and just call initialize, right? Up here. And inside of our button here, there's a couple other functions, right, to kind of call out in here. We'll just not have it play the animation at the start.
No, why don't you just let it play once at the start and we can replay it later on?
Okay. Yeah, let's do the simplest possible thing that can work here, right? Yeah, because I can sense that you're kind of stressing out about my ability to
It's been a long time since I've seen anything run, John.
Whoops. So we'll come back to here. Let's go run this thing, and there we go.
Okay, I'm feeling comfortable again.
Okay.
You can start hacking.
All right, so now that we have this, let's make the animation playing trigger, right, based on the click. So if we come back here to app.rb again, there's a couple of things we can do here. We can go play animation here. And get rid of that. We don't really need that anymore. So we'll play the animation. But to make it a little bit more interesting, rather than kind of taking that canned set of things that we have in there, why don't we instead just inject a bunch of our own things right into there to see. So again, back in this file, there's a function called clear list that we're going to now go off and use. So we're going to clear the list, and now we're going to go off and inject a bunch of stuff in there. So as an homage to my son who loves the alphabet, we'll put a few letters of the alphabet in there. And this is exactly the way we would do this right inside of Ruby, right? So there's a block here, and we're going to go js.initialize name is another thing that's in that function. And so that's just going to iterate over each character inside of that string, right, and inject those letters, right, into the page. So let's see what happens. We'll refresh this thing here, we'll click, and lo and behold, right, we see the alphabet.
So do you have a clip of your son singing the alphabet song for us now?
Well, we need to do that next, yeah. We had limited time, right, to get all the media assets in place right, for this stuff. But now we have 3 languages, right, running inside of this application, right? We've got some Ruby, right? We got some C#, and now we got some JS running in there. And actually, it's interesting. JS is doing all the heavy lifting here. Later on, you can look at the sample of the code. You'll see that it's actually calculating all the positions of all those things as it's going.
So there's a mini 3D engine inside of JS there running in order to figure out where each of those text blocks should be.
Awesome. Okay. So, but can we do more?
So, yeah, and you know what? I'm actually feeling really bad because, my first favorite dynamic language we haven't shown yet.
I know, but you will have your day in the sun, John.
Okay. No. My first favorite, which was BASIC.
Oh, your first?
The first.
That's right.
The first language that I learned to love.
He actually has an IBM PC BASIC 3.0 manual, right?
Yeah.
Sitting in his office, right? One of those. Remember how everything came in these boxes and with a little, the little case for the binder and stuff? Yeah, one of those.
I'm still getting used to not typing line numbers, but other than that, I'm doing good.
Yeah, that's right. So there's another sample that we'd like to show you, which is this Technorati sample. And so this thing here was written inside of VB. And of course that's going to happen,
Does that mean your network's dead?
So let's go off and, no, it means that something, I did something dumb, but that's okay.
Okay.
So we have that, proxy.cgi, we do this, and we have no network, that's why. Yeah. Okay.
So if you look at that code very carefully, you'll notice that rem in the middle.
All right, we'll make this work. This is our disaster recovery here, right? Apparently the network just decided to go south.
It's our cached version of the network.
All right. Oops. All right, so we get that. I love having the rem back in there, right?
Yes.
Brings back some nice memories. So if we go off and we rerun the sample now, you'll see that it just goes off. So what this thing would have done, had we had a network running, is that it would have gone out, and this is actually really cool, right? We're going to use the Technorati API. The Technorati API itself only has an XML-based interface to it, right? But there's this guy out there that wrote a Yahoo pipe, right, that goes off to Technorati, grabs the XML, and then serializes back to us as JSON, right? So we're kind of going through this kind of funky infrastructure right in the middle. Once we got the JSON, we're going to bring it back, and we're going to deserialize it back on the client.
And you guys are going to have to take our word for it that we did this last night with a hardwired Ethernet connection.
I did this like 10 minutes ago, right?
And built that Silverlight.json file.
Yeah.
This is what Technorati's top 10 were last night. So, mostly true, but.
So the interesting bits here, right, are to call out that the fact that inside of the 1.1 stack is that we do have a networking stack here, right? So that's what the do web request code does up there, and it should be relatively familiar to anyone that's done any .NET networking code before. And what's really interesting about this sample is, outside of all the weird, spooky, like URLs and strings and stuff, is this little thing right down here, right?
Okay, I've got to ask the audience. Who in the audience recognizes that line of code? Does that look like any VB you've ever seen before?
It's link. Right. And this specifically is link over objects right now, right? So what we've done is we've retrieved some stuff, right, from the server as JSON, deserialized it back into an object, and now we're going to use a link query to query over that in-memory data, right, that sits on the client, right? So, and this is just link, right? So later on, you can write the adapter to do the smart thing so that you can write the appropriate query there that actually goes out to Technorati, right? Or whatever the endpoint is that you want, right? Just build your own driver, right, for this thing. Right, so that's really interesting as well, right? So that you can go off and use link inside of Silverlight from a dynamic language with all this other stuff.
Miguel.
So the request that you're doing over there for HTTP,
Yeah.
isn't that typically on the web forbidden for you to do arbitrary connections that do not come from the originator?
Yes. You're absolutely right. So the next line of code, right, you'll see that there's a proxy.cgi there. Right, so I bounce this off the origin server right now, right? And I have to have, this is why I need an origin server here, right? So I bounce off the origin server, go off, and come back. Yes.
So we haven't created a new breed of, these cross-domain scripting attacks, just in case.
Yeah. But clearly, right, since we can do a lot of this stuff in JS today, right, this is something that we really need to think really hard about, right? Because this is a scenario that people want to do, right? And since you can already do it today, right, inside of JS with script hacks, right? Anyways, okay. So let's kind of take this code here, right, this technorati.vbx code, and let's inject it into our application. Right, so Jim, please entertain the crowd while I copy stuff.
Oh, okay. So yeah, I'm working on it. Do you want me to? Give me enough bottles and I'll juggle something. So let's see. I wasn't sure what I wanted to talk about at this point, but so John's going to copy all of the VBX files over. He's going to do the same sort of thing of requiring it in order to bring it in. Part of the point here, right, some of this, we talked a lot about how to show you guys, the fact that the DLR runs all 4 of these different languages, right? Our first thought was, well, okay, we were going to code up some simple sample, and we were going to write it in Python, and then we're going to turn around and redo the same sample in Ruby, redo the same sample in JavaScript, and redo the same sample in VB. Pedagogically, that could be sort of interesting, but I think half of you would have left by now, so I'm glad this seems to be working better than that. But this was, John hit on this idea which really struck me. What's exciting about this is what I imagine actually doing in the real world. This is what I like about the fact that all of these languages run on .NET. I personally, however much John tries to convince me, I'm starting to warm to Ruby, but I'm going to continue to want to write most of my code in Python. But other people are writing cool code in other languages. Other people are writing these cool 3D text things in JavaScript, or are writing these nice link engines in VB. Adding link to Python is a whole other fun thing to do, but it's not going to be there for a little while. People are going to be writing cool things in Ruby, really soon, I suspect, and building things in C#. I want to be able to use all of these things that were built in other languages. So, the model that we see here of why you should care about the multi-languages is your favorite language is there, but everybody else's favorite language is hopefully going to be there too, and you can use their cool stuff. So this is kind of the model of what we're doing here of using all of this other cool stuff that people have written. We got a really obscure VB programmer to write this VB one for us, right? We went out and found Paul Vick.
Yeah, And
hey, there are a few people in the audience who know Paul. To write our VB code for us, but...
Yep. So what's interesting again, right, was all I had to do here was do the require of the technorati.vbx thing there, right?
Wait, you're already done?
Man, it takes no time at all to do this stuff, right? Especially when you've practiced for like days. So vb.getTitles, right? We're going to go off and just grab Silverlight there, return this items. This items is essentially the result of that link query, right? That came back, and then we're just going to iterate over that, just like we iterated over the string before, right? Using the standard, idioms inside of Ruby now, right? To go off and do this. So let's see this thing run. Of course, I didn't copy the JSON file, so I always forget to do stuff like this. So let's rerun this thing, and there we go.
Okay.
Woohoo!
So that's the universal
Thank you.
people are saying about this. Do you mind if I'm pedantic? Can you go back to the code? That event handler, I just love that event handler. And, some of you, maybe you have to be a languages geek to love it. But, if you look at that 3 or 4 lines of code under button.click, that's a Ruby event handler responding to an event that comes from a C# button, calling a JavaScript method with the result of a list that it got back from VB. You're only missing, wait a second.
It's okay. You're going to get your moment in the sun, right? I know you just can't wait to show off your skills, but we're almost done, right? There's one last thing that we need to at least show you guys so that this will be complete. And that is obviously we've hard-coded, Silverlight, right, as a string in there, right? So in order for us to accept input from the user, right, you will feel a little bit of pain, at least initially, on this stuff, right? And that is, since there isn't a built-in, text box control, right, inside of, the controls that ship with Silverlight, what we're going to do in this case is we're going to go back to HTML. Right? So we'll show you integrating back into the DOM in the HTML page to go off and grab something the user types in, right, and injects it into here. And of course,
you're going to have a pain doing this in any language but Python, John.
No. Well, so here's the thing, right? And Jim is actually right about this. Even though we all work on the DLR, there are times in which stuff just surprises us, right? And the Ruby implementation is, a little bit kind of hacked up. Yeah, that'd probably be the best way of describing it right now. And to get things to work, right? But yet, a lot of the things that we did in building the Ruby demo that we're showing here, we were adhering to concepts inside of the DLR. So some things just happen for free, right? And sometimes you just don't expect this stuff to work, right? So that was surprising was in Jim's hotel room last night. We were just going through this little thing, and lo and behold, something just worked that I just had no idea, right? I did not expect that to work at all. So let me show you that little piece. If we go back to app.html, we're going to need to add an input element here. Yeah, HTML. Oh, brain is input, right? ID is equal to search term. Okay, so this is what some user is going to go off and type up here. And if we come back to the Ruby code over here, what we now need to do is reach into that DOM, right? So let's do it by grabbing the document object. And this lives in a scary place, system.windows.browser.html page.document, right? Okay? So just create that little alias there. But now, if I want to get a term, what I need to do is just walk up to document. But now document references the HTML DOM, right? And if we go back over to the HTML DOM, remember the ID for search term, this control here is search term here. And it's value, right, for pulling out that thing from there. This will be, again, a little bit contrived because we're not going out to the network here, right? Okay? But we're just going to pass that input term into the other thing. And if we just go off and we run this thing, again, I can type in, DLR, and it will return me Silverlight results. That just worked, right? And again, right, maybe you guys are just going, well, but shouldn't that just be the way it is? Yeah. But even in this really early state, right, the fact that that just worked, right, was something that really just surprised me.
So, and what's going on there is, right, there's weird dynamic language lookup going on in order to put this attribute, search term, on top of document.
Right.
And the weird dynamic language lookup, we designed to make work for Python the first time around, and happens to just work for the other three languages.
Exactly. Yeah. So that's
okay, so did I get to talk about how we got here?
Sure.
Thanks.
I know you've just been dying about to talk.
So could you guys switch back to the, do you have anything more you want to show here before I?
Nah, I think we're done with this.
Could you switch back to the PC? So that was our demo. Ah, perfect. Okay.
All right. So we're done with
I needed to get to that slide.
To remind him of what to say. All right. So if you think about it, right, like you've been at this thing for a long time, right? I just joined in January, right? So most of this stuff is history, right? As far as I'm concerned. But so really, what was the big challenge, right, of kind of building this thing?
Yeah. So this is where I need to tell a little bit of a story about how I even got to Microsoft. So in some ways, what we're doing with the DLR is a reflection of the common language runtime thing that Microsoft announced a long time ago when .NET first came out. Right? When Microsoft first announced .NET, they said it was all about this common language runtime where you could run whatever language you wanted to. I wasn't working for the company at that point. Anybody here working for Microsoft back when they announced .NET? Yeah, one of you could probably explain this better than I can, but I saw it from the outside, and I saw it from the point of view of actually somebody who was working on Java at the time. And everybody who was working on Java was making fun of this common language runtime thing because they thought Microsoft was out of their mind. And where they were particularly making fun of it was in the space of dynamic languages. So again, my favorite language was Python. And people tried to get Python to run on top of .NET in the early days. And what they found was it ran incredibly slow, and it did not interoperate with the rest of the platform. But other than that, it was great. So I heard this, and previously I built an implementation of Python that ran on Java called Jython. And people use Jython. Jython's running on real servers today. So Jython runs well enough on top of the JVM that people can use it. It doesn't run quite as fast as the native implementation of Python does, but it runs pretty well, and people were able to do real things with it. So what I want to know is how Microsoft screwed up so badly in creating this new common language runtime that it was worse than the JVM for running dynamic languages. So I set out, I had some spare time. I decided I was going to take a couple of weeks. I was going to build a quick implementation of Python running on top of .NET and figure out why they screwed up so badly. And I was going to write a little pithy paper called How Microsoft Screwed Up .NET for Dynamic Languages. So I did that. I went out and I started collecting numbers and seeing how fast it ran. And so I pulled out the standard Pystone benchmark. This is the same one I used in the early days of Jython. It's the one that ships with the platform. And I said, OK, so how fast does this quick early implementation run? And my first measurements, it ran faster. And so, of course, then I go back and I say, OK, well, I'm doing something stupid. One of my loops is running by an order of magnitude too few iterations or something. And go back and no, it's actually running faster on top of .NET. It was running faster than I'd ever seen Python run. And that was really disturbing. So, with this whole Pystone thing, so the numbers on Pystone, right? It's all measured in numbers of Pystones per second. So Python 2.3 has like 35,000 Pystones per second, and they improve it in the next version. It gets up to like 45,000, and the next version it gets up to like 50,000.
Whoa. Wait a second, right? I think this would be a good time to actually show the one and only PowerPoint slide, right, that we have in our deck that actually contains content, right?
So this is the slide that you spent all last night building.
Yeah, because that's what us designer guys
do.
So
this was Python 2.1. Let's see 2.3. So the Python team, the compiler writers who work on Python, make it faster on this benchmark every iteration. Python 2.5 got a little faster. It gets harder and harder to make it faster. As you all know, when you're trying to engineer performance improvements to something, right, you start hitting a wall. This was IronPython 0.1. This was my first prototype of what it would be like to have IronPython running on top of .NET. And this is when I realized that my whole plan of making fun of Microsoft was unfortunately thrown out the window. And I have to say, anybody who's ever tried to do things like blogging and interacting with communities, it's a heck of a lot easier to be on the side of making fun of Microsoft than on the side of trying to support them, having gone to OSCON on both sides. But the good news was it worked. It worked really well. So I went and I joined Microsoft. I joined the Common Language Runtime team, the .NET team that builds this framework that IronPython runs on top of. We took IronPython all the way from an early prototype to a full production release, IronPython 1.0, which we released about 7 or 8 months ago, which people are using, building real apps on top of, doing really cool stuff. I love to see the kinds of things people build on top of the languages that we work on. So IronPython 1.0 was fast. And, of course, since then, we've been working on making it even faster. So this is 2.0 Alpha 1 running on top of the DLR. I think we got a long way to go from here. But what this is showing is that we're on the right kind of performance curve. This is the kind of curve that you want to be on. And a lot of the performance work, right? The performance work from 0.1 to 1.0, that little jump, OK, so that was a little bit of tuning inside of IronPython itself. The next set of work, that's all platform work again. The tuning work that made that get faster wasn't Python-specific work. That's platform work to make all the languages run faster. So there's now this platform and this performance curve that people can hop onto when they want to start having their code run faster. So this was what was sort of the positive things about IronPython. When I joined Microsoft 2.5 years ago, right, it was for 2 reasons. One, it was to work on IronPython, but it was to work on IronPython with a very specific goal, which was to make .NET better for dynamic languages in general. So in some ways, I feel like now it's finally come around. I'm finally getting to do what I originally came for. First, we had to build one complete production quality implementation of a dynamic language to learn what it took to do it, to get all the corner cases right, to deal with all the weird language semantics and know that we were doing things right. And now we get to go and build the platform.
So what was it like when you guys were talking to the community, right? Because at some point, right, when you're building a language, it's really important to interact with the users and the community at large, right, to understand, the kinds of things that they are passionate about, right? So we showed one example, right, already, right, about things that the community is passionate about, and that's what method names look like, right, inside of Ruby. Yeah. Right? So we do this name mangling thing, right, where we will translate .NET names, right, to Ruby names, allow you to call them that way, as well as allowing you to call them using the .NET names if that's what you want. Right? If you notice closely in our sample, we called it both ways. right, in the code.
So
but that's one thing.
could we switch to the Mac for a moment?
Sure. Mac? Mac. There's the Mac.
Oh, this is going to be interesting. Okay, so I'm going to actually bring up here a sample that I'm going to want to talk more about later, which was this was the sample that you saw in Scott's keynote earlier today. All of this code, interestingly enough, for this little mini Silverlight app was written in Python. I'll talk to you more about that later. For now, I just want to use this.
I know you can't resist.
I can't resist. I like it. It was fun. So here in Python, I'm creating a little test string. Right? And the interesting question that we ran into, and this was not what we expected people to care most about. I have to trick out IntelliSense to make this interesting. So this part of our story is we're integrated with .NET. So this is a .NET string. This is the same string that you would use from C#. But a Python programmer expects to have Python methods on it. They expect to be able to call this method called upper. So one obvious point about IronPython is, that sure as hell better work. Or you're not building Python. If you're going to tell people you got to learn a whole new set of string methods in order to program in Python, that better do the right thing and better turn everything to uppercase. On the other hand, we have this interesting case of, OK, I'm a .NET programmer. I know that this is the way that I turn a string to uppercase. It's a .NET string. I don't want to learn a whole new set of APIs in order to work with strings in Python. This sure as hell better work. And in the first version of IronPython that we released publicly, this completely worked, because that's what we believed was true. Funny thing was, you'd think that that would be obvious, right? Everybody should be happy now. The Python programmer's happy.
What they wanted, right?
The Python programmer got the method names that they wanted. The .NET programmer should be happy. They got the method names that they wanted. We thought we were done. We're going to show you what we did at the pleading of the Python community. We made that one throw an exception. Now, OK, how many people are pissed off about that decision yet? Anybody who likes the .NET APIs? OK, this is the wrong crowd. At PDC, I get a whole ton of people who are pissed off about that decision. So the reason that the Python community wanted us to do this was Python places great value on uniformity of code. That community places a lot of value in me being able to read anybody else's Python code that they wrote anywhere and having it all look the same. And that's a particular value that that community places a lot of importance on. So they didn't want a bunch of .NET programmers starting to write IronPython code that looked like regular Python code, but all of a sudden, when all they were doing were string operations, they were calling this capital 2 string thing that didn't look Pythonic. They wanted us to throw an exception to make sure that people wouldn't go and do that. OK, so this was good, but the .NET programmers weren't very happy about this, right? Python programmers were right. This is what we need to do if we want to call ourselves a true Python implementation. Because Python strings don't have this method. So we did what we had to do in order to call ourselves a true Python implementation. That was important. But we also wanted to make the .NET programmers happy. And this is kind of why I wanted to bring this sample up was the hardest thing about doing IronPython was this balancing act. It was this balancing act between being true to Python, being true to the languages that we were implementing, not going out and creating Python Sharp or some weird derivative of this language that we've turned into something that's really easy to make run on .NET, but being true to the language, but also being true to integration. We wanted to be true to the fact that we really like the story that you can use .NET objects really easily, and that you don't need to go learn a whole new set of libraries to learn a whole new language. So we worked really hard to come up with the right compromises that let us live between those two worlds. So in this case, the compromise that we came up with was import CLR. And if you import the CLR, you now get a whole new set of methods on your Python types. And let's see. So you get two car array, all of those sorts of things. Two car array is something that a Python programmer would never think about asking for. It's just bizarre. But you get two upper. And this works on a per lexical module basis. OK, I'm going to get way too geeky but I'll do it briefly. Yes?
I'm not familiar with Python.
Yeah.
That's not upper changing the string? Or
No, strings are immutable.
Okay.
So it's returning a new string.
Okay.
And both of them do the same thing. So that happens to work well. We could talk about Ruby's mutable strings, but
it's a whole other discussion.
That's a whole other long, interesting discussion. So here, and so the interesting thing here is, and so we bring in the CLR methods into Python, and we bring it in on a per source file basis. So I can have my pure Python source files, and I can have my .NET plus Python source files. And that makes the community happy, and it makes the .NET developers happy. Funny thing about this is the same mechanism that C# 3.0 and VB.NET's latest version use called extension methods, where they let you bring in additional methods onto types. We're using that same thing, and the same lessons that they learned we're building on, which is this notion of tying it to per file, which makes it a lot easier. The usual dynamic language approach would be, let's just toss all these methods onto every string in the world. And that works, but it doesn't scale very well. So we're trying to take advantage of some of the good dynamic language ideas, but also let it scale and take advantage of some of the modularity things we've learned in other places. So that was the hardest part of IronPython.
Yeah, and I think that when you think about the different communities will look at this differently, right?
Yeah.
So, you know, since the Python community is a little bit more closeted and more kind of straitjacketed about this kind of stuff, right? And Ruby's kind of more like the hippie free love kind of thing, right? Your types are my types, and my types are your types. And so the Ruby community would be perfectly okay, right, with that union solution, right, where, you know, that would be the case, right? Because people monkey patch stuff all the time, right, inside of Ruby. But that's the interesting cultural thing, right? To be able to make sure you have that continuing conversation, right, with the community, so that people really do, you know, realize what you're up to, and if they do have concerns, right? The idea is you have to listen. You don't actually have to do what they say, but it's very important to listen, right? Take the feedback and try and make, you know, an informed decision about those kinds of things as well.
Okay. It's time to talk about the sample.
I think I'll let you talk about the sample.
You'll let me talk about the sample.
I know you've been like just jumping up and down.
Like
to be honest, right? Jim worked really hard on this thing. This is 2,200 lines of code or something like that.
It's about 2,000 lines of code.
Yeah.
So the fun thing about the sample, I should tell you the story behind the sample, which was this sample I started work on about 2 weeks ago. And I started it initially because I wanted to flesh out the bugs in the DLR before we shipped Silverlight. Right? This was everybody was doing app building. It's a standard thing. So I wanted to write a bunch of Python code in order to find out what was wrong about the experience. I have to say, the first day that I started working on this, I found out just about everything that was wrong about the experience. Because I found out that, you know, if I threw an exception in my code, 90% of the time it would be silently eaten, and it would just disappear. So I could throw any exception, and I would never hear about it. And the other 10% of the time, it would crash IE. The fun thing about this was I still found it kind of fun to be writing Python code that would run in the browser, even with that sort of awful error handling experience.
This is binary search debugging, right?
Yeah.
Yeah. Just cut out half the code and see if it still runs. And, yeah.
And it was less painful than Ajax programming to me. But then, over time, it was also great to watch as the people who were building this worked on solving those kinds of rough edges. And Silverlight's still an alpha release, but it's not a pre-alpha release anymore. So this was built on the pre-alpha bits. The alpha release does have nice error messages that pop up in the browser if you do the wrong thing. We forgot to make a mistake during our sample to show them one of our beautiful error messages. Next time, we'll work harder.
Worked really hard on getting that pretty error sample.
It's supposed to happen once during the talk.
Yeah.
So, you know, worked on the error messages. I haven't seen either IE or Firefox brought down in quite some time by Silverlight. So it's getting to be a lot more stable and a lot more fun to develop on. The other thing about working with Silverlight is you have to build just about everything from scratch. So if we show you, just briefly go to the code that's involved here. So here's the DLR console sample. And let's look at this giant PY file that contains everything. And you know, it contains everything from my own versions of stack panels, divided stack panels with panes, to, let's see, what's the worst one? The text input handler is definitely the worst code in the whole thing. This is some of the fun, though, of playing with an early platform, right? There was this horrible blocker that text input was not working very well, but you were able to get the raw key codes. So you could work around it and make things happen. And there weren't blocking issues. There weren't things that said, well, I can't make it do what I want to do. Except, yeah, numlock and, oh, yeah, the Windows key is Windows only for today. That's one of my favorite comments. I don't know. Maybe that's a world domination plan hidden in the code somewhere that you guys, you know, I'm going to get in trouble for just having revealed that.
That made it past Polycheck, though.
The other part that was really fun was we'd gone out in the past and built a bunch of code for playing around with editors and handling things like IntelliSense. And that code had all been written targeted at a completely different editor. But the fun thing about dynamic languages was all that code worked, and it worked great against the DLR stuff underneath. And I was able to take that same code and just copy it into the DLR, again, the whole stealing code approach, and use that same code against this different console written on top of Silverlight. And I think I had to change 2 variable names somewhere in this code to get it to do the right thing. So I was able to work with all of that stuff that was already there. So let's go back and take a look at the console. A few things that it does. So it also has a XAML editor in it, which is kind of fun to play with. So I can change this to say something like MIX07, and reload, and I've now edited the XAML. I can do my classic developer fun. I like large fonts. I don't know why I like large fonts, but somehow they satisfy a deep-seated need for me. I also have this little bit of Python code that I can execute, right? So I can go to this chunk of Python code, run it. The XAML's getting in the way. Let's go through. This was fun doing the gradient selection stuff, by the way. That was. So I can go there and go back to the Python code and reload, and now I'm running against that simpler XAML code. I can edit this stuff. So let's go. So when I touch it, what I've done is define some Python functions that assign some callbacks. So when I enter and leave, the text does a little bit of highlighting. It edits just fine. So let's say I wanted this to be yellow instead of white. I run that, nothing happened. Well, I updated all of the callbacks and got the right thing, right? I've always thought that this seemed a little bit offensive, but I'll do it anyways. Not quite sure what that means. Get up to my larger font size. So here I can be playing around with this code, not necessarily just in a console form, but in this little bit of code that I want to be running. As I make changes to it, it's all working live, and I can keep playing with it. And kind of this edit, the standard edit, compile, run your code loop is basically a no-op here, right? I edit the code. I hit Control Return because that's the only key that seems to be recognized in all 3 of the browsers that we run in. And it just executes the code and does what I want it to. OK, let's go back. I'm going to clear my canvas. So I'm going to go back and just load this raw canvas. Yes, Miguel?
Is it OK to show what would happen if you have an error there in Python code?
If I have an error in this Python code? Sure, let's see what happens. So let's see, what shall I do? Font size equals. I haven't tried this error. So I do that. My error reporting's not beautiful. It pops me back to the console. Shows me the syntax error, though. Shows me the line number, shows me where it was, shows me that I had a syntax error there. It would be great had I had 3 weeks instead of 2 weeks. We could have had a little editor window pop up down here, but I had 2 weeks. Yeah? OK. So now I'm down in the console, and I've got a blank slate. And that's kind of fun. I always love having a blank slate. So I want to load up a few things to put into this window so that I can start playing around with them a bit. So things I'm going to load are, I'm going to load a text block. So you'd think I'd use the IntelliSense if I had it, wouldn't you? So this is a little text block that says DLR. I'm going to get a photo. And I've learned my IntelliSense lessons. Wait for things to pop up. Load XAML. There we go. And I've got a couple interesting pieces of XAML here. First one I'm going to load is a logo. Just a second. I want to use the names I used the last time I ran this for testing. And I'm going to load one other piece of XAML. And this is a lovely picture of a jaguar. Who took that picture of a jaguar? Where did we acquire that one from, John?
I don't know. I found it on the internet somewhere. No.
OK. More power to you. John, for those of you who don't know, is an amazing photographer. So it's his photo. And I'm going to stack all of these 3 things into the canvas. So I'm going to stack this DLR picture. So let's put the logo on top, because it looks a lot better than the DLR. Jaguar and this DLR. This is just a little helper function that I use, this WPF.stack. So I've put all of these things into the canvas, and I can now do things with them. Except, well, those of you who've ever seen me give a talk before know that I'm just not going to be happy with this until I've increased its font size larger. This is also what happens when you type an error in the browser. Miguel, I know you wanted to see a syntax error here, too, so you're welcome. Now, moving along from there, so I have these 3 little objects sitting in the browser. Now, I've written another helper file that I want to show you the code to, because this is back to the same story that we did before. And this is a little animation file. And this is another story about workarounds. It turns out that the animation support in Silverlight 1.1, Alpha 1, only in the Alpha 1 release, requires you to load XAML code. You can't do it programmatically except by loading XAML. Fun thing about these dynamic languages, though, are they do all of these fun games with string manipulation. Right? We've played these games before, so this is back to the standard old HTML things we did. So this is a little Python helper file that plays games with string manipulation in order to generate the right XAML to do some animations for me. So I can go back and use those animations. And let's see. So here are these animations that are set up. We're going to work with wipe. Yeah, I like wipe. And we're going to wipe the DLR. So it does that standard sort of animation that you've seen before. Ooh. For those of you who've missed it, let's do it slowly. Yeah, much more impressive. OK. I can this is just to prove to you that no designers were involved in the creation of this talk. I can make this wipe at a sort of reasonable pace, and I can stick it in a little timeline object. And I can play around with this a bit. So let's set the repeat property. Does it have a repeat property? Repeat behavior. There we go. And yes, of course, we always want things to repeat forever because that's our desires for the DLR. And it looks a little bit ugly, so let's make it auto-reverse so it looks a little bit smoother. OK, now we can just sit back and watch that for the rest of the talk.
But really, right? Like, while you're making fun of this, right? The really interesting thing here is you can experiment with these things, right? You can compose these different named animation elements, right, together, right? And from code, right, do a lot of this kind of stuff as well, right? Because, well, certainly you go off and load this stuff up in Blend, right? And do all that fancy stuff, right? But here, it's just, I don't know, like, for me, right, as a developer, there's just this visceral experience of having dots and stuff, right? And being able to type all that.
But let me show a little bit more about why I want to be able to do this from code, in addition to being able to do it from XAML. And the standard way that you get a good animation, by the way, is you have a really good designer build it for you in Blend, and then you import the XAML. But you can do that, and you still want to be able to apply it to objects. So let's go through and do this from a couple of the languages. So we're going to have JavaScript make this Jaguar do something. So the way that we would do that is, let's see, we still have this object that I defined in Python. For those of you who didn't notice, this is the other feature here. I'm switching between languages in the same console. So pay attention to the left side of the bar to know what language I'm in, or it's going to get really confusing. And here I've got the same sort of functions, and I can do mouse left button down. This is one of my favorite features of JavaScript for this sort of thing, are these anonymous functions and this ability to not pass it any parameters. So this is an event handler. And ordinarily, I have to do this s, e that I don't care about. Well, JavaScript lets you call functions with fewer parameters than you want. Usually that annoys me, but when I'm building these event handlers, that's really kind of useful to be able to do. So we're using that feature in JavaScript, and of course it just works because it's a JavaScript implementation. And here I can call this same little Python support library of somebody who wrote some cool things for me. And we're going to just fade the Jaguar. And we're going to make it take a little bit of time. So we're going to fade it over 2 seconds. And close curly brace. That looks good. Hope I got it right. So now when I click on it from JavaScript, I fade the Jaguar. And I'm able to use these functions. OK, so let's do something from Visual Basic. First thing I always have to type when I do Visual Basic, and this is back to this was my first programming language. These 2 loops with steps somehow embedded themselves in me at an early age, and they bring back fond memories. So now I feel like I'm back to the Visual Basic time. The fond memories that they bring back are real, though, right? I remember Visual Basic just as being so incredibly simple to use. That may be because my second language after Visual Basic was assembly code.
Like everybody, yeah.
But I remember it as being this really simple language to use to do things. So let's try and do the same thing in Visual Basic. And we're going to do pop it, which needs to take in that sender and event. And the way that you'd ordinarily do this in Visual Basic is you'd add a handles clause. All right, so you'd add a handles canvas dot mouse. Anybody here a VB programmer? Yeah? OK.
Nobody's admitting to it.
Oh, OK, well, if nobody's admitting to it, you're not going to be frustrated this doesn't work. This was a little depressing. VB is missing a feature. It's missing handles clauses in the DLR. So how do we solve that? So we can't wire up event handlers today in VB. That's really bad, right? Well, let's define the function in VB anyways. We're going to make it pop the logo. And let's throw in some mixed casing just to make it fun. I like to type everything all lowercase, but VB's case insensitive. So I've now defined that in VB, but let's go back to JavaScript to wire it up. And this is one of the fun things about the multiple languages again, is right, we realized there was no way to wire up events in VB. But that's not a showstopper, because there's ways to wire up events from the other 3 languages, and they can do the VB functions just as easily. So I can go to logo, mouse left button down, pop it. Okay, now when I click on the logo, it pops using the VB function. It's able to wire it up just fine. Okay, now I want to finish it off in Ruby. And we're going to see what John has managed to teach me over the course of this talk. Because I'm going to try and do a whole integrated thing in Ruby, and I have to tell you, I'm somewhat scared. Okay, I'm in Ruby. You notice my IntelliSense is giving me a different set of methods, which is really helpful, because I would have never managed to type that correctly without the IntelliSense.
I helped you once, though. Actually, no, I typed it. That's right.
Okay, so I'm going to do something, and it's going to take in a sender and an event. Okay, and I'm going to start the block. And then I'm going to do, this is the thing that I never get used to. Ruby's for loops are either the one true way or completely backwards, depending on your attitude. So for every item in the canvas, I'm going to do anim.spin item. Oh, no. I've learned better. I've learned better. Okay, so I'm going to spin every item. And in the block within a block, this is the most complicated Ruby program I have ever written. And click on the desktop, and everything spins.
So we've got 2 seconds left.
2 seconds. I think we should take 2 minutes to do the origin of the DLR.
Sure.
And that'll start the conversation with the audience. Because the origin of the DLR, and this we had in our talk, and I don't know quite how we lost track of it. So people sort of wondering, how'd you get from IronPython to the DLR? And I didn't do that bridge. And the bridge was, we did IronPython. People said, that's cool. I love that interactive experience. But I want this language. So can everybody guess what language I was told everybody wanted? Shout it out.
Ruby, Perl, JavaScript.
Thank you.
Exactly.
And at Microsoft, Thank you. All of them. That was the problem. So I first went, I'm on the same hall with the team that builds Blend. And I went and talked to them, talked to John Gossman, and he said, we need JavaScript. That's it. That's what our users want.
That's all we care about.
Of course, then I went across the street to the team that builds Visual Basic and was talking to them, and, well, okay, that's not interesting what they had to say. I went and talked to the team who work on systems like Office, and they told me the same thing the Visual Basic team did. We want Visual Basic. That's, we have more programmers in Visual Basic than any other language. You're an idiot to build tools that don't support Visual Basic. And then there's, these people who like to be on the bleeding edge who keep saying we need Ruby. And I think John made that a condition in his contract, that he'd only come work for us if we'd agree to do Ruby. So I think it was a fair trade. So everybody wanted a different language, so we couldn't sit down and just do one. So this is sort of a dream, though, to somebody who really likes computer architecture, right? If you have to just do one thing, well, you got to do it all specifically. If people want 5 or 6 different things, you've got a lovely excuse to go out and build a framework for everybody to build on top of. So we took the 5 or 6 languages that people wanted as our excuse to go out and build a framework and build this DLR piece so we could make building all of the different languages on top of it easier. And the DLR has 3 pieces to it, and that's going to be the entire architecture that I'm going to talk about. But the 3 pieces that we did to get all the languages to talk to each other, or you can ask me questions, was a dynamic type system. So that's a shared type system so that I can be calling functions from one language in another and passing messages to them and iterating over their lists and all of that stuff. By having a shared type system between, that works great. Shared type system between the dynamic languages and with C# and VB.NET and with these existing .NET languages. Next one is a shared hosting API. And that means when we host one of them inside of a place like Silverlight, where people might want to run inside of the browser, you get all of them. When we host one of them inside of something like the DLR console, you get all of them. It took me an hour to get JavaScript running after I had Python running in the console. That was because there were some bugs in our API design. It should have taken 5 minutes. After we'd done JavaScript, VB took 5 minutes. Sat down with the VB team for 5 minutes, and VB was up and running in the console.
Actually, they just had it work. I don't think they did anything.
Yeah, this is true, actually.
Right? And that shocked you.
5
right?
minutes sounds better than 0.
Yeah.
Nobody ever believes me when I
right.
tell them that it just worked. I don't know. I didn't believe me when I told me that it just worked. Ruby took more time, and the Ruby bits are just coming together now. So it's the language, we started working on it when John joined us.
And it wasn't even that, right? Like, we only really there's maybe 4 weeks worth of dev work, right, inside of the Ruby that we showed here.
So we've got a ways to go in the Ruby implementation, but I sat down and wrote that code last night that I just showed you there, and that's pretty sophisticated Ruby for something that's 4 weeks in. So that's how we got there. Oh, and then the third thing is a bunch of helpers for compiler writers, so that when they write their compiler, they use our mechanism so their code runs really fast. And that's what we learned in the early days of .NET was if a compiler writer does a poor job writing their compiler to target your platform, everybody says the platform sucks, not the compiler does. So our job is to make the platform much, much easier so that compiler writers won't do a poor job targeting the platform so that they'll say so people will stop saying the platform sucks for dynamic languages. And now we should take questions. Yeah?
Oh, plug the sample site. We have no internet, so we can't actually... Oh, there it is.
If you can read that.
Yep.
So we have several of these samples ship as part of the standard Silverlight SDK, this DLR console that I showed you, and a version of the Jaguar stuff that you saw in Scott's keynote. We have a bunch more samples of how to do interesting things using dynamic languages on Silverlight on this Codeplex site. Here, and that's an open Codeplex site, so if you want to add your own cool samples to it, let us know, and we'd love to have you adding them in.
Do you think that's going to be broadly replacing the ActiveX script host?
So there's a big difference between
This is actually a really important point, right?
and the ActiveX script host. And the big difference is security. So the big difference is the platform. It's this platform that you get to play with. But the thing that I find makes all the world of difference is the security sandbox that we get to run in here. I'd have loved to have showed you our earlier versions of the code. When we had bugs in like our Python code generation, where we were generating invalid code that would lead to things like buffer overruns and horrible things like that, we'd get a nice error popping up in the browser once we were able to get nice errors in the browser, saying you generated invalid code, I won't run it. All of these languages are completely security transparent. What that means is that they're running inside of the Silverlight engine, and it's its job to be secure. And so long as the basic Silverlight engine is secure, the languages can't cause trouble.
Yeah, that was my question. My question was,
okay.
is going to replace the ActiveX scripting engine broadly?
Oh. So are you talking about iScriptHost?
iActive script
iActive
host?
script host?
Yeah.
So not anytime soon. I mean, these kinds of APIs stay around forever. We would like to see it as an alternative to the iActive script host, particularly for people building managed applications and for running in other environments.
So I think the question is, will IE use that?
Will IE use that?
Use.
Default.
Yeah. By default, so IE has the same situation that everybody else does, right? For backwards compatibility reasons, I don't see something like IE changing anytime very soon. Silverlight, we're running this in Safari, but if you run Silverlight inside of IE, you can host your languages just fine this way.
Yep.
Yeah?
I have two questions. So the first one would be, could I use the DLR from inside a console app or a WinForms app or an ASP.NET application?
Yeah, absolutely. Yep.
And the second question is...
Wait, we should probably be repeating the questions, or people should come up to the microphone.
Yeah.
I just want to be sure that we captured for this. So the question was, can I use the DLR from other things like ASP.NET or inside of a console app or in other environments like that? And the answer is absolutely. You can use it anywhere that you can use .NET. It's more constrained in Silverlight. In Silverlight, it won't do things like file.open because that's an API that's not supported.
Yep.
And if you run it on the client, you have access to everything.
.NET, there was a talk yesterday.
Yeah.
Demoed much of the dynamic language usage based on.
Yeah. And the ASP.NET Future CTP has some integration of dynamic languages on it available, I think, in your bags.
So the second question was, is the dynamic language runtime actually compiling an assembly, or is it just executing it kind of as a text file in place?
So
Because the app domain will
I'll
grow
take
and
it.
grow and grow if you keep changing the file and pumping it back
You know,
through.
so that was, and you saw those pictures of IronPython 0.1, that was its worst bug because it was compiling everything into an assembly. In .NET 2.0, they added a wonderful feature called dynamic methods. And what these are very lightweight methods. You can compile a single method very quickly and efficiently, and the methods are garbage collectible. So we use these dynamic methods for all of our code generation. It both lets us generate code lazily, so we often don't generate code until we're just about to execute it. And we generate it as a dynamic method, which means we hold on to that code, including the machine code that the JIT turns it into, is only held on as long as there's a reference, as long as there's a live reference to that code. And as soon as all the live references to it go away, it disappears. Part of how we know that this works is the ASP.NET scenarios where folks are running web servers where they're hitting thousands and thousands of pages. And when you do a stress test on that, you'd find out really quickly if we were holding on to the code for each page, and we aren't.
So it's using method rental?
It's not using method rental. It's using the specific API is dynamic method. It's system reflection dynamic method, emit dynamic method, and it's using those dynamic methods, and they give you this garbage collectability, this collectability of the code.
I was just wondering what relationship the JavaScript in this DLR has to like JavaScript.NET, which has been around but hasn't really been supported much or been developed much, it seems like.
We use
So
some
is
of the
this the
libraries.
future of sort of JavaScript in .NET or unknown?
So the relationship to JavaScript.NET, JavaScript.NET came at the problem from a very different point of view. They wanted to take something that looked a lot like JavaScript, but really emphasized the seamless interoperability with .NET. So they added a ton of stuff to JavaScript. What I'd say was, to me, the experience from JavaScript.NET was that that's not what developers are asking us to do. They didn't like that very much when we added a lot of stuff and changed their language to feel like a different language. It was seamlessly integrated with the .NET, but it wasn't JavaScript anymore, and people didn't like it very much. So I think we've learned our lesson. And it's amazing watching Nandan down there in the front row is one of the lead implementers of JavaScript on the far right. And he has this dog-eared copy of the ECMA spec. And whenever we're getting in one of these discussions about, I make fun of, you can't be serious that you really can call a function with fewer arguments than is declared in it, right? You're out of your mind. And he'll point me to the right place in the spec and say, no, that's JavaScript. That's what you do. So a big part of this is, we're being really serious about this as an ECMAScript 3 implementation. We want it to be as integrated well as we possibly can, and I think we're doing some great integration with it. But it's first and foremost JavaScript, and that's something that really sets it apart.
And some of us are also very jealous of that dog-eared copy of the JavaScript spec that he has because he has a spec, right? So you take some other languages that don't have a spec. And,
where's your free love now, John?
It's a painful thing. So I think we're like
are
way
we
out of time now. So you guys want to come up and ask us some questions, we'll stick around. But thank you all for coming.
Yes.